So, welcome to episode 194, which is an episode I've been looking forward to. So I get to talk to Martin and Jan about this little thing we've been cooking. So before we get started, just Martin and Jan, can you just quickly introduce yourself, and then we can jump into it?
Yeah, sure. Jan, do you want to go first?
Okay. Many of you have probably seen me, at least in some of the previous episodes. I've been working on Quarkus for a few years, and now lately I've been working on the LangChain4j project and its integration into Quarkus. So I'll be talking mostly about the client-side aspects of the MCP protocol.
Okay. So hi, my name is Martin, and you probably also have seen me here in sites many times. And the last 2 weeks, 2 months, I was working on the MCP server thing, which is why I'm here today. So hopefully I'll have some information for you.
Yeah. And we had to move this start about half an hour earlier because of everyone had a meeting conflict suddenly. Let's get started. I'll switch over to my screen, and so the thing we're going to talk about is model context protocol, or my subtitle here is like if AI won't go to Java, then Java must come to AI. And the best way to show this is actually, is what this enables. So here I'm using Claude Desktop. You can use others too, but Claude Desktop is the one that does this most nicely. So you can talk to an LLM. So I could, for example, say, what is in my database, right? So normally an LLM won't have access to a database, but in this case it actually has. And you'll see it's calling some tools here. So this is where the model context protocol gets into play. And we'll get into detail how that works, but just to show what's going on. You see it's doing different tool calls, and it sees, there's some tables and databases I have access to. And I say, great, please make an ER diagram. Right, so Claude here, one of the nice things with Claude Desktop is it has this visualization part. So in a few seconds, it should be kicking off on the right and generating a mermaid diagram of I think this is a Northwind database, which is like an old classic database layout. And boom, I have an ER diagram I can browse from into, right? Then you go like, well, if you have access to the structured data, how about access to the data in general? I say, okay, any interesting trends to extract? And again, this is just a normal LLM. The LLM doesn't have access to anything but these tools. And you see it's just the model is making up queries based on the structure. And it's a bit different every time. This is sales trend, performance trends. And so it read through them. And it should go, let's see, this is a long one. Yeah. It starts generating visualizations of it. So here it's then taking the data it queried, generating I think like a React thing, and boom, now we have visualization of the data, right? So that's the kind of thing we can enable with the model context protocol to have your LLM accessing data. We'll get in more specific examples of how that works, but just to give an idea what happened here was we had an LLM, that is on the left side, and then we have external services. So for example, in this case, I have a database. It could also be like a Slack or chat or a Google Drive or Microsoft Exchange Drive or your own file system or any kind of crazy system you have. You want to be able to give access on the right side. But you have all these clients, like the desktop client here from Claude or someone else, want to talk over there. Well, they could implement it in their own language, but just like IDEs today is using this thing called LSP, where the IDE is written, for example, VS Code is mainly TypeScript, but the language support for Go is written in Go, the Java support in Java, etc. With this protocol, the same thing they're applying here, just for model context. And so we want to get them to talk. So the model context protocol lets you get these kind of tools, as a list of tools or prompts or resources and sampling. These are all different things. So, but in what we show today is mainly about tools, but it's important to know that MCP is more than just the tools. It also can like access files and resources and that kind of thing. But the cool thing is then that you can implement servers that can access these things, and normally they are like being written in Python or JavaScript. But what we'll show today is how to do it in Java, and specifically with Quarkus, where it becomes much nicer to use and do than any other of these. At least that's our claim, so to speak. And yeah, that's the context of this protocol that came out. I guess it was like late November or December, and I think we had an early version of access late December, and then we came back from the break, and Martin and Jan just did magic, and yeah, that's where we want to go and show. So, Martin, well, Jan, you want to start?
Okay, so I'll show how to I'll present the client side. That's inside integrated inside the LangChain4j project. So if you use LangChain4j, and specifically the
Jan, can you zoom in just a little bit? Can you try zooming just a little bit?
Yeah, sure. Yeah. So if you use LangChain4j for your AI-infused application, I will show how easy it is to connect to an MCP server and integrate that with your application that's based on LangChain4j. If you use the Quarkus extension, here you just add the dependency, and you provide just a piece of configuration to tell your application how to run an MCP server by itself. In this case, I'll be using this server file system server example that's from npm. Yeah, you here in the configuration file you declare how to run the server. So in this case, you provide the actual command that will that Quarkus will run for you. In this case, npm exec which server you use, what version, and the playground is the directory that I've created for playing around. It's inside this project. Here, there's just one file that says "Hello World," and yeah, this will get this when you run an application with just this piece of configuration. It will actually run this MCP server called server file system, and this is a server that provides operations for interacting with your local file system, obviously. So
so just to give I think a little context that I forgot to say was that not only is this relevant for implementing the server, but here you're implementing the clients, all right? And this
Martin,
the cool thing,
sorry.
I'm just saying that you can have multiple of these, right? You have a file system here, but they're named like data sources, like you could have a Kubernetes or a database or something else as an additional one here, right?
Yes, you can have any number of them. Name them. I named this one file system. Another important part to mention is this transport type. We can currently have two transport types for the protocol. This one, stdio, it means that Quarkus will actually execute this command and run it as a sub process and connect to its standard input and output, and that is how they will communicate together. The other option is using the HTTP protocol and server send events. But in this case, I will just use the standard input output. So this is how you simply declare how Quarkus should run it, run the server. And yeah, that's pretty much it. I will show you my declaration of the AI service. It's quite simple. It says that you have some tools to interact with the file system, And yeah, the only directory that the server will be allowed to access, to use, is the playground directory inside this this project. Yeah, by the way, this project, if you want to give it a try, it's in the Quarkus LangChain4j GitHub repository.
Cool.
And so I've created this one directory with one file so that we can test it. Yeah. If you just simply run this application, I'll run it in dev mode.
Zoom in.
Quarkus dev. And let's let it start. And yeah, I will show the application. The application in the repository comes with a very simple UI that where you can connect to the robot, and it gives you some sample prompts suggested the suggested prompts to try out. So let's say read the contents of the file hello.txt. That's the file that I have created in the playground directory. So yeah, you see that the robot has access to this file and can read the contents.
Cool.
Let's try reading from a file that doesn't exist. Hello2.txt. The file hello2.txt does not exist. Okay. Let's try something a little bit more complicated. Here it says write a Python script that does something and save it as adder.py.
Yeah, so this is the Quarkus app written in Java, talking to a Node script, TypeScript.
Yeah, the server is written in TypeScript, as far as I know. Yeah.
It's basically three languages playing together here. That's what's
yeah. So yeah, it says it successfully created the script. It also printed the contents here, but let's just make sure that the file is really there. Yes, it's here, right here, adder.py. Yeah.
Cool.
I can briefly show what the protocol does, what it looks like. Yeah, here that's what happens after Quarkus starts. That it actually started this process using this command npm exec blah blah blah. Prints the process ID, and here because I've enabled debug logging, you also see the actual messages of the MCP protocol that run on the standard input and output of the server.
Do they run? Do we run them actually aggressive, like up front, or do we only start them when we start calling them? What's the?
You mean like if we start the server eagerly, or what?
Yeah.
The server doesn't seem to start eagerly. I see that after I started the application that there was some seconds delay. Yeah, I think it started lazily.
Okay, cool.
Yeah, so here you have an example of what the protocol looks like. This is initialization message that the client server sends to the server. Here you also see the log from the server itself. This is the message that the client receives from the server, where the server declares its protocol version and its capabilities. And then the client sends this message that everything is initialized and they can start talking together. And when you actually, when the user actually asks the first prompt, the client needs to retrieve the list of tools that the MCP server actually provides. And that's this message here. It says method tools list. That means, hey, MCP server, give me a list of tools that exist on this server. And the result looks like this. It's a huge JSON document that declares the operation, the tool names, read file, with each has its description and its input schema, which is a JSON schema that defines what the arguments for the tool are. And then when the framework or when the LLM actually decides to execute a tool, we send the server this message, tools call, and we say that the name of the tool to call is read file and the arguments are hello.txt. So this is from the first prompt that I used to read the contents of this file. And here on the next line, we get the result that the text of the file is hello world.
Yeah, so it's basically just like a remote procedure. It's like a simplified REST protocol or something like that. Just
yeah, something like that. Yeah.
So if I may, I wanted to know the one thing that it's actually pretty cool that Jan did not write a single line of code and the client is working, right? That's what the MCP and the standardization is for, because the protocol is standardized, so any MCP server behaves in the same way. So that's cool.
Yeah, and there's like massive catalogs, and you can just kind of add them in. Yeah, very cool.
Yes, and the only specific code that I actually needed to add in this application was a proper system message to give the LLM some kind of context what the users will be talking about. But it would probably work even without this system message. So I didn't really need to write any Java code that's specific to MCP. I just declared the server in the application properties file, and that's it. Quarkus will take care of everything from there.
Very nice. Cool. Anything else on the client side, Jan?
That's it from me, unless you have questions or anybody from the viewers has questions.
None yet. There are a few people on, but if you are listening, ask any questions about the subject, then we'll happily answer. But maybe once Martin starts talking about the server, where things gets a bit more dicey, we can do. So, Martin, well, let's see what we can do.
Sure. Okay, so now the server part. Unlike Jan said, Quarkus MCP server is a separate extension. It's a Quarkus extension, and it's a young project. So we started to work on this like 2 months ago. So contributions are welcome, and also feedback is appreciated. And the main goal of the MCP server of this extension is basically to provide an API for developers so that they can write the MCP servers using all the Quarkus goodies and also the idiomatic style of programming model and so on. So I prepared. So what I have here is a very simple, regular Quarkus project. If you look at the POM XML, you'll see that the only extension or the only dependency we have is our Quarkus MCP server. And as Jan already mentioned, MCP defines something called transports. So transport is a pluggable thing that basically defines how a client communicates with the server. So we're going to show the SSE transport, which is basically based on HTTP plus server-sent events. So basically, the server sends messages to the client using server-sent events, and the client is using regular HTTP post methods to send data or messages to the server.
Is there actually any different? Like we had a quick chat with Mark yesterday. He was asking, when I use SSE, I can do more things concurrently. But the client, so the STO is also concurrent, isn't it? Or is there any limit there? Or?
Well, if you use the standard input-output, then the client starts a new process with the MCP server. So it's always one client, and it starts a new process that only serves this client. Unlike in SSE case, where you can have one MCP server started, and it can serve as many clients as you want, because it's a regular HTTP server. Speaking about the concurrency, so I believe that you can have concurrent requests using standard input-output as well. But I don't know whether it actually makes sense in that case.
Well, you can call multiple tools at the same time if your application has multiple users at the same time, but there's only one application connected.
Yeah, we should probably also mention that MCP also defines not only transports, but also the protocol, how basically there is a big JSON schema that describes the messages that are sent to the server and back. And one of the crucial part of this is that when a client sends a request to the server, it sends a request ID, and the response from the server also contains this request ID. So it's always easy to, pair the response and request. So it can happen concurrently. There shouldn't be any problem. Okay, so back to our simple demo. So we have only this dependency. As I said, we decided to show the HTTP SSE transport because it's easier given the fact that we can show, Quarkus dev mode easily and so on, which is not so easy when you use standard input and output. And in our project, we also have two more files. One is application properties. We basically use this just to enhance our development experience. This one is very similar to what Jan showed, that we want to see the JSON messages that are coming to the server, and we want to see the messages sent from the server. And this one is here because so far the development mode could be a little bit tricky. So what we do here is that we enable instrumentation of reload in Quarkus, which basically means that if you change, for example, a method body of your class, we don't necessarily do the full reload of your application, because otherwise all the state would be lost and we would have to reconnect the client. And we also have an empty class here. We're going to add a very simple tool here. And I wanted to explain at this point what we actually do. So Quarkus MCP server is basically a simple declarative API that allows you to basically annotate your methods of your CDI beans. And these methods are automatically exposed as MCP tools and resources or whatever. And the good thing is that when I can start writing something here. I will return a string from my method. What was that? Favorite number. So we write a regular CDI business method here. We're going to allow an AI agent to basically call a tool that will return a favorite number. It's very stupid simple demo, but it should be enough for our use case. So I will just first I will just write the method body, which is very simple. I'll say if Kouba is equals the username, I will just return 14, which is my favorite number. Otherwise, I will throw a new exception. This is a special exception that is translated into special error message. So we're going to say user. And now the important part is that we want to use some annotations to basically define our features, MCP features. So I'm going to use annotation that's coming from MCP server. It's called tool. And one of the most important thing we add is the description of our tool. And it's really important because when an AI agent discovers all the tools that are available on my MCP server, it reads the description and it helps them in the context. So I will just write get the favorite number of system user. And then we can also, in this case, in case of tools, we can also add parameters to our tools so that it's the client part can send some arguments. So we have another annotation which is called tool arc. And again, we'll add description, username of the system user. Forgot to new. So this is it. This is all the code we will write in Java. And we use two annotations that are automatically processed by the extension. And under the hood, it basically collects all the, the method signature and the annotations or the metadata we provide. And then when the client is basically calling the server to list all the tools, then we will return some metadata that basically reflect these annotations and meta description.
And here's that: if you go and if you try the Python and Node stuff, or other Java versions, you all have to like manually configure the JSON, like the schema, and return it back. And it's very flexible, but extremely hard to get right. Where this is just kind of like I have existing code and just add annotation.
Yes, really nice. We basically want the developers to focus on their logic, right? We don't want them to write all the messages under the hood and so on. That's why we basically support this kind of API. I also wanted to mention that since we are working with Quarkus now, if you annotate this class with tool, it automatically becomes a CDI bean. So you can, for example, inject your other services. You can use interceptors and, I don't know, for example, a transaction or whatever you're used to, even security stuff and so on. So that's what it's not visible. We wanted to basically follow the principles and the user experience from other extensions. Another thing that is important that in Quarkus, we also support reactive programming model, right? So what we wanted to support here is that if you want to use, for example, Hibernate Reactive in your tools, you just return a uni string from Mutiny and that's it. We're basically following other extensions such as, I don't know, WebSockets, REST, and so on. Okay, so now I'm going to run my application in the dev mode again. Hopefully it starts. And I wanted to show you two more things before Max show some cool stuff. Okay, it's very slow today.
That's not cool.
Okay, I wanted to show one is a Node.js tool which is called MCP Inspector. So I'm going to run this application, and it helps you when developing an MCP server, so you can easily inspect. What is it? Open link. So this is how it looks like. You can connect to your SSE's. MCP server. In our case, we're going to use SSE, and I already have it pre-filled. This is the endpoint that is used to initialize the SSE connection. So I'm going to connect to my server. It's connected. That's cool. And now I can inspect all the components or features registered there. I can immediately see that I only have tools deployed on my server. I can list the tools. It returns me some information about the tool. In our case, it's name, get favorite number, description, and it also has some input schema that is used to describe the parameters. And I can even run this tool. So if I just say foo, this returns an error because we have unknown user. If I look back to my application, where is it? Here. Okay, I can see some exceptions, but the important thing is that we can see the responses, requests and responses on the server. So this tool is really really useful when you're developing the your server and you just want to see what's there and whether the correct syntax is used and so on. Okay, and the other thing I wanted to show you is actual usage of this MCP server. So I'm going to show Goose, which probably Max is going to show as well. Goose and especially Goose CLI, it's an open source AI agent. Can be configured to talk to several LLMs, and then you can also add your tools there, which is important for us. So I'm going to say Goose configure. I'm going to add a remote extension because we are using SSE, so we need to connect remotely. I'm going to name it what is favorite number, and now I need again start with the endpoint URI to initialize the session. So it's HTTP. Oops. Localhost 8080 MCP SSE. This is the default for MCP server written in Quarkus. I don't want to add anything. And now I'm going to start session. Session, I guess. Okay, so it tells me that it discovered my MCP server, which is great. And I can try to ask the model for so that my tool is used. So what is the favorite number of user Kouba? Now, what you can see is that the CLI tool actually called my tool. And if I look back to my application, which is running in the dev mode, I can see that it sent the message. This is again, as I talked about the JSON schema. So this is a JSON RPC message that has all the parameters and method name and so on. In case of tool, it's tool's call, and we use an argument which is called username, and the value is Kouba. And we just replied, we just basically invoked the method, which is here, defined on our CDI bean. We invoked the method and provided some data to the AI engine. So we just replied 14. And then Goose, under the hood, there is Gemini, I believe. Yeah, Gemini. LLM decided to return this string. Okay, so that's about it from my side. Are there any questions?
So that was you made a MCP survey in less than 7 minutes. That's a pretty good.
Yeah, I also wanted to show that the dev mode still works. So let's try if I change the value to 15, and if I repeat the question. Okay, right? It works.
Awesome.
So
very nice.
It's quite cool, and of course, as I said, it's a young project, and we're still working on new features and improvements. So any feedback or contributions are appreciated.
Awesome. So let me. Oh, I'm just gonna. Okay. Awesome. I'll switch back to my screen if I could. Yeah, that works. So yeah. So what we've gone through here is that Jan was showing the client talking to via MCP protocol server to a service. So you did the file system, which was implemented. So this was like Quarkus LangChain on pure LangChain, maybe Quarkus LangChain on the left, talking to a JavaScript TypeScript implemented file system, right? And then you generate a Python app with your Java code. So it's like all combined. And then Martin was doing the middle here, the taking the writing a Quarkus app with his very complex financial favorite number guessing game, and then he used multiple clients. So he used the inspector and Goose, right? And that's the important part here. Is like all these, like there's multiples of all, right? So on the left side here are current clients that is useful. That's Cloud Desktop, which I'm showing here mainly. There's the Goose Desktop, there's Goose CLI that you showed that works, I think, in all major platforms. The desktop is only on Mac for now, but I'm sure they'll evolve. Continue Dev, you can also use these things in IDEs that supports this. So if you use Continue Dev or Cursor AI, you can refer to these tools and resources. LangChain4j is what Jan was showing. The actual framework is a client. And another thing to mention here is if you use LangChain for like Python or any other stuff, they also believe have support for MCP and can call these servers, right? And there's a bunch of servers you can go. There's a bunch of catalogs out there. But you can find stuff like a Playwright server, a Jira server, Obsidian, Google Doc, Docker, any kind of thing you can think of. And then I was thinking, hey, okay, cool, but what could we actually do in the Quarkus Java space? So about, I don't know, 3 weeks ago, I kicked off and said, hey, I would like to re-implement the file system in the Java version. And then suddenly I was like, oh, there's the web API, JWC, and suddenly that got there. And that's what the last part here is, kind of showing some of the examples we've made and introduce you to that stuff to, inspire you to try some of these things out. And so we actually created Martin talked about Quarkus MCP server, which is the framework. And then I had to come up with a new name, which is really, really hard. So I had an MCP servers. So there's an S in difference. And this is a set of samples of different servers. So right now we have JWC, we have file system, we have JavaFX, and a Kubernetes. So let's just go back and show that. So the one I showed in the beginning, this thing about extracting data, was actually JWC, right? And this is and you can actually go out now. There's already MCP servers for this, but the special thing about this is that it's JWC, which is in Java, which there's a ton of different drivers for. And that means that it is, this works with any kind of JWC driver. So I'll just give you an example. Where's the code? There we go. I'll just go in and show this. So the way you configure it, so you saw Jan was saying, hey, property file server npx all the way out. That's for the LangChain. For something like Cloud Desktop, you put in this piece of JSON, and you give it basically, hey, I want to have a name and a command and arguments. So here, I could just use like Java, jar, have a jar somewhere, but we use JBang for this, because then we don't have to deal with installing Java, get the right dependency, and that part. It just does it for us, just like npx from Node, or what's called pbex from Python. That's all done. So we have this JWC Quarkus MCP servers project, and I can just then take any JWC UL, and I can then use, where is it, like, these are the ones I've tested and verified, like MariaDB, MySQL, Postgres, Oracle, all done by the same server. And it just works. So that means that now with this, you can do what I've done here, with an SQLite database. You can use Postgres, Oracle, etc. But you can use that in any project. You don't even have to know about Java. It will just kind of work for you. I want to show you the code because it's kind of ridiculously small. And I just hide it here. I hope you guys can see it. Oh, it's very tiny. Let me zoom in. It's a big. I thought. All right, go away. Here you go. And this is the fun part, right? Because you start recognizing like this, what the Martin was showing, like add tool, execute a select query in the JDBC database. Read query is the tool name, and then just arguments like the query. And this code here, if you use the JDBC, it's just doing a query and returning the results. But this could be any Java code. But this is all there is to it. And we then do stuff like write query and list tables and create table, describe table. And I basically have access to a full kind of database system here in less than 175 lines of code. And you can do the same thing for your enterprise app. So I think even like you're guessing code with like 20 lines, 5 times more code, we have a database introspection tool, right? And just to go further, where's my Claude? I need to get to my Claude. There we go. Let's just do some crazy stuff. So let me do a new chat so this is a bit more clean. We'll say, how about drawing a car on a canvas? So again, I'm just using plain English to talk. So now it's no longer, it's going to look in the different tools I have. And there's one that's called JFX. I can draw on canvas. And it failed for some reason. Oh, that's not good. Well, bad demo. Now it starts giving up and then it does its own thing on the kind of thing. I'm not sure what happened here, but it should have opened a JFX window and did a drawing. Like in this little demo over here, you'll see here it's just basically started up. I'll show the video instead. And you see it's just drawing commands and drawing on a canvas. And again, that code is, well, I'm losing my windows here, is again fairly simple. So it actually, there's a guy who made a JFX extension for Quarkus, and he just uses that in here. So there's stuff like launch a canvas. Again, then if you know JFX, this is JFX code. Description, close canvas and draw a line, draw a rectangle. Again, just kind of exposing these business methods with a description, and then the LLM can work on them. The other one is just, so again, I could start talking about Kubernetes to Claude, but now I'm just going to show from Goose, again, a different client, but the same kind of service. So here I'm saying Goose session with extension, and I think Martin, you use the SSE approach here. With Goose, you can actually put the actual tool on the command line, so it's easy to switch between. So JBang, Kubernetes, and then the server. And we start. And on the left, you'll see my cluster, my OpenShift cluster. And I'm just going to ask, like, what is in my cluster? And yeah.
Is this actually real that Senator Hawley proposes jail time for?
Not sure why I'm going to shoot. There we go. I hope you guys can hear me because I have radio playing in the background somewhere.
We can hear you, Max.
It says that the namespace is empty. I have nothing. So I'm just gonna create the terminal at OpenShift. And it starts up. And you see it starting this service, and I'll say, what is there now? And there we go. I need to figure out why my computer is suddenly. Yep. There we go. All right. So you can see now the web terminal executing and the tooling. But what if I want to create my own little setup? It's like, can you create a web app and expose the port in my cluster? And again, this is an LM and can be a bit random, but it should then go like, hey, I can start an NGINX application and boot up, and you should start seeing the cluster getting started. And again, note I'm just speaking normal English to this. So it's running, and yeah, you see it's going up there, and it's red, so something is wrong. It is not running. What could be wrong? Again, mind you, this is literally the LLM using these tools to reason about this community space. Like, we haven't done any kind of extra stuff. And it should never go and say, hey, it's running restricted permission, and figure out this. This is an issue with the LM. It's saying I have rate limited the token size here. But anyway, let's try. Let's see if you can retry here. It should then come up and say, hey, this image is not for OpenShift. You need a more specialized one. And I'm hitting rate limit, so I can't. I'm stuck on this thing. There's the thing that's playing. Let me go back. You can hear me. The whole point here is that we can do all these different things with extremely small amount of code. So, for example, the Kubernetes one, I'll show it in here. Again, this is using the Kubernetes client that comes from Quarkus, and it's just saying, hey, what's the configuration, what's the namespaces, what's the pod, the get, delete, etc. And what is this? It's like 200 lines of code, and you now enable any of your LLMs to talk to your setup. So yeah, that's the magic of it. And I see Petro has a question here. You tested its SUPA-based MCP. Do you guys know what that one is?
I don't know.
Let me just. I'm gonna risk it and Google it. The connection. Oh yeah, so these are just a list of servers. Yeah, so these all work. Like I was about to say, of all the servers that actually works in like Inspector or somewhere else, these all work in Quarkus for that. The line chain, it's a very similar protocol. It's that's a nice thing. It's very hard to make it wrong. It's a similar protocol, and it's fairly like simplistic. And that's part of why it's kind of grown that big, that it's there and available in so many shapes and forms. For example, there's MCP SO. I think, I'm not sure. Do we have the Wildfly here? Yeah, you see, for example, the Wildfly MCP was actually, so this is the Wildfly team who implemented the Quarkus MCP server where you can talk to the server. So all these are available, and yeah, all these, the ones I've tried have all just kind of worked in our setup. So if you have like any idea or crazy thoughts, like you can just try it out today, create it with the Quarkus MCP server. And if you make one up that's like small and could be useful, even as a demonstration or even like a real thing, like the JWC here is actually useful for non-demo purpose, but like real stuff. You can go down and Quarkus MCP servers, and there's like instructions on how you contribute an extension. A server. And on top of just being available to run, we actually also a wonderful thing with Quarkus is that we can do native binaries, right? So we talked about you can do Java to manually download your Java and run it. You can use JBang to just not have to deal with that part. But you can also actually use native. So any of the products we have that can run in native, so the file system one, the Quarkus one, are available to run on any platform. So the advantage here is they start faster. But for example, the JWC and the JFX is, because they do dynamic, some more dynamic stuff, is not suitable for native. We could actually make JWC native, but then we have to bundle all the drivers, and it becomes huge. So yeah. No, I think did we cover everything? Time flies. Any comments from you guys, Martin? Anything we forgot to say?
I think that we covered everything, hopefully.
Yeah. No. So if any of you want to try it out, the products are there and explore. And I think it'll be interesting to see all the stuff that people makes with these. So yeah, cool. Well, then let's keep it short. And sorry for the 30 minutes shift, but the recording is online.